Hello. So today we're going to start diving into the next unit with bonding. To actually start, going into bonding and seeing what it's all about, we really need to know how to notate certain things in regards to how electrons move, where they're positioned. So what we're going to do is we're going to focus on Lewis dot structures or Lewis dot diagrams and the naming of just basic ions in this video. So the basics of Lewis dot structures. They represent the relative position and number of valence electrons surrounding an atom. So it kind of gives us a rough idea of how these electrons are organized within the shell and how or what type of bonds will be formed with particular ions. So the first thing you need to do is you need to write the correct element symbol. So in this case, I'm just going to use carbon. And then we determine the number of valence electrons for the selected atom. Well, we know carbon is in group 4 of the representative elements, therefore it has 4 valence electrons. And what we do is for each valence electron, we draw one dot and we start at the top of the element symbol. So I'll draw the first one, and then each additional valence electron after that, I will start drawing one additional dot in a clockwise motion until all the valence electrons are accounted for. So there's the second one, third one, and fourth one. So what this says is that carbon is able to form bonds in 4 different positions here, because the thing is that each electron wants to be paired up with another, and so due to that it's able to form 4 particular bonds. If we look at oxygen, we know that oxygen is in group 6, therefore it has 6 valence electrons. So we have 1, 2, 3, 4, 5, so that's the first pair of electrons, and 6. Well, since there are 2 pairs of electrons, they don't really want to bond unless absolutely necessary. So what this is saying is that since oxygen has 2 valence electrons that want to be paired with other electrons, it wants to form 2 bonds, so that way it can occupy or have 4 main pairs of electrons. Because if you have the 4 main pairs, then you have 8 valence electrons, and if you have 8 valence electrons, it reaches that octet rule, or represents a noble gas. We can look at calcium. So calcium has 2 valence electrons, but we know calcium likes to form a cation. So it has the 2 there, so it's going to want to lose those 2 to bind to something else. So for example, you can make calcium oxide, where calcium will lose these 2 electrons and give them to oxygen, so that way oxygen becomes octet with 8 electrons, but calcium loses the 2, and therefore the valence shell below the shell that it has right now will be octet, and they're both satisfied with the amount of electrons that they have. Fluorine has 7 valence electrons because it's in group 7. So we know based off this, it has 3 pairs of electrons. So it actually only wants to form 1 bond because it only wants 1 electron. So demonstrating charge with Lewis dot structure, the ionic nature of atoms can be demonstrated by it. So what we do is we write the correct Lewis dot diagram. So for calcium, we have 2 valence electrons. And for nitrogen, since it's in group 5, has 5 valence electrons. So if the atom has 3 or less valence electrons, erase the valence electrons from the diagram, and that will demonstrate that it's losing electrons, so it's becoming a positive ion. It's becoming a cation. If it has 5 or more, you fill in the remaining spaces that have no paired electrons to make it octet. And that demonstrates that it's gaining electrons, therefore it's making a negative ion. And then if it has 4 valence electrons, it can gain or lose electrons. So for example, carbon can lose or gain. It just depends on what it is. So you just make sure that if your carbon's losing electrons, then you're going to make it a cation. If it's gaining electrons, you're going to make it an anion. And then to finalize this, what you do is you put brackets around the diagram, and then you put the numerical charge on it. So since calcium lost 2 electrons, okay, you lose that 2 minus, therefore it has an overall charge of 2 plus. Okay, so for every electron that you lose, you do plus 1. For the nitrogen, since it gained 3 electrons, it's gaining 3 additional negative charges. So for every electron that you gain, you add a negative 1 to the charge. So therefore it has negative 3. When it comes to naming conventions of ions, it's pretty simple. So for cations, which are the positive ions, again, it's just the name of the element plus the word ion. That's it. So for example, the calcium ion that we did, we would just say calcium ion. So Ca2 plus is just calcium ion. Magnesium is just magnesium ion. Hydrogen will be hydrogen ion. Now, hydrogen will typically form a cation, but it can also form an anion. I'll talk a little bit more further with that in class. Because since it's so close to helium, it only has to gain one electron to be a noble gas, but also it can lose one electron to become a cation. But 95% of the time that you deal with hydrogen, it's going to want to form a cation, and 99% of the time in my class, it's going to want to form a cation. But it is possible for hydrogen to form an anion in particular instances. Anions are negative ions again. What you do is you eliminate the suffix at the end of the element name and you add IDE. Now the suffix is different for each element, so this kind of, you have to play around with it and you'll get used to it after you start hearing the name. Typically what I would do is that you would want to write it out, enunciate it, and see if it sounds right. Most of the time, if it doesn't, it's probably not the right spelling, but it's going to just come with practice. So for nitrogen, when it turns into a negative ion, it turns into nitride. So you get rid of the OGEN and you add IDE. Oxygen is the same thing. You get rid of the YGEN and you add IDE and you get oxide. And then fluorine, you get rid of the I and E and you add IDE and you get fluoride. So that's the end of this video, kind of really basic and simple. But if you have any questions or need further practice, please come talk to me. We can kind of break it down step by step if we need to. Definitely start practicing your Lewis dot structures because that will become very important as you go further on in chemistry and within the course itself this year. Thanks for watching this video, and I hope to see you in the next one and see you in class. Bye.